Okay, so hello guys. So today's our topic is gonna be dividing. It's gonna be dividing polynomial. Okay, it's actually going to be dividing polynomial, right? So basically, there's not many really important property you're talking about. So basically, we just go straight to some real example. Right, so we're just gonna go straight to the real example. So we got tons of questions over in this section. Yeah, we got tons of questions in this section. Okay, so let me see. We actually got 12 questions in this section. Yeah, we actually got 12 questions in this section, and as always, focus on if you already know how to do some of the questions, then now is the time for you to skip it. Okay, otherwise I will talking about those questions in really detail. Okay, so hopefully you guys does understand it really well. Okay, so let's move into question 1. Okay, so question 1, you can see over here is that we got 18x to the power 6 over 9x to the power 2, right? So you can see over here, we can actually cancel 9 and then 18 become 2, right? We can actually cancel 9 and then 18 is just simply equal to 9 plus 2, right? So 9 get cancelled and then there's only 2 left. And all the thing else is we have x to the power 6, x to the power 6 over x to the power 2. So it just basically become x to the power 6 minus 2, right? So it's just gonna be equal to 2x. 6 minus 2 is equal to 4, right? So what we have is x 2x 6 minus 2, and then 2x 6 minus 2 is equal to 4, right? So now we actually solve question 1. Okay, so now we actually solve question 1. All right. Okay, so let's move into question 2. So question 2, so we haven't talking about anything about factory yet. So if you actually know how to do in factory, so okay, no factory. If you actually know how to do factoring, then this question is pretty much really easy for you. Okay, but if you don't, I was talking about factory right now. Okay, because if you actually know how to do in factory in this problem, then everything will become really easy. Okay, so basically let's talking about the things right now. Okay, a little bit detail. So you can see over here we have 5 as the denominator, right? So we have 5 as the denominator. So before, okay, so one thing I want to talking about the factory. One thing you have to know is the JCF, which is stand for the greatest common factory. Okay, the greatest common factory. Okay, the JCF. So for example, over here at the numerator we have a 5 and then we have a time square, right? At the numerator what we have is a 5 and a time square. So the JCF over here is actually equal to 5 So you may ask me why the greatest common factory between 5m and a time square is actually 5m, right? So let me explain you a little bit. So you can see over here time is actually equal to 5 multiplied by 2, right? Okay, so let's move it down a little bit. So the JCF, okay, the greatest common factor over here between those two terms is actually 5m. Okay, so you can, let me explain. Okay, so we have turn 5m, and then we have a 10m squared, and 10 is actually equal to 5 multiplied by 2, right? And then you can see 5 is the common one, right? 5 is the greatest number, and is the common one, right? So you may ask me why we don't choose 2, right? Why we don't choose 2 as the greatest common factor between the number 5 and 10? Cause 2 aren't common, right? 5 is just simply equal to 5 multiplied by 1, right? 5 is equal to 5 multiplied by 1, and then 10 is equal to 5 multiplied by 2. 5 and 5 is the greatest number, and the common. The common means that that number have to be in both of them, right? So common means have to be in both of them, right? So common means, and the greatest, as the words already say, that it should be the biggest. It should be biggest, and then common means the number have to be in both of them, right? And then 5 is equal to 5 multiplied by 1, and then 10 is actually equal to 5 multiplied by 2, and 5 is the greatest, and then it appears in both of the number, right? So you may also ask me again, why 2 is not? Cause 2 is not. Cause 2 is not common, right? 2 is not common, so that's why you cannot choose 2 or 1, cause those are not common, right? So right here, you know, between the number 5 and 10, the greatest common factor have to be 5, right? Right. So right now I'm talking about the number. Between the number 5 and 10, you know the greatest number have to be 5. Right? Okay. And then on the other side we have right? We have and then we have a square. So obviously we cannot choose square, because square is not in 5m, right? So remember, in 5m, so we have 5m to the power 1, and then 10m to the power 2, right? So obviously you have to choose in the common one, right? We have to choose in the common one, the one appeared in both of them, right? And the greatest over here is it is not m squared, because m squared are not in both of them, are not the common one. Makes sense, right? So m squared is actually not the common one, and m is the common one, and it is the greatest. So for the variable, it's gonna be m. So you combine those together between 5m and 10m squared. The greatest common factor is gonna be 5m, right? It's gonna be 5m. Right? Now things will become really easy. Okay, so now let's go back to the question. Let's solve the question, okay? So now you're getting the common factor. Now you're getting the greatest common factor, right? So you write it down 5m, right? And you know 5m multiplied 2m is equal to 10m squared. And then we have plus 1. Makes sense, right? So for 5m, we have to multiply 2m, right? So we have after 5m multiplied by 2m, it becomes 10m squared, which is exactly as the denominator, right? Which is exactly the same as the denominator. And then 5m multiplied by 1, 5m multiplied by 1 is equal to 5m, which is exactly the same as in the denominator, 5m, right? 5m. So now you know, basically things become easy, right? So now you can actually cancel 5. right? So you can, after you cancel 5, all the thing left is just 2m plus 1, right? 2m plus 1, right? So the answer will be, so we have to simplify, right? We have to simplify. It just basically become 2m squared plus m, right? Okay. So now after that we just need to simplify a little bit, right? So it become 2m squared plus n, right? Okay. So now we solve question 2. Let's move on to question 3. So question 3 is the same thing. You look at it, you know you have to find the JCF, right? So you have to find it. But now I think after I really detailed talking about on the previous question, I think right now we're gonna speed up a little bit. Okay. So right now what we're gonna do is trying to finding. I'm just going to show you guys how you actually finish this question really fast, and then how to find, the JCF, greatest common factor, as fast as possible. Okay. So write down equal, and then you look at the denominator. You look at the numerator. Okay, you look at the numerator. You notice that 8, the number 8. Will be the greatest common factor. The number 8 will be a part of the greatest common, will be a part of JCF. Because you can see over here, 8 multiplied by 2 is actually 16, and then 8 multiplied by 3 is actually 24, and 8 multiplied by 5 is actually 40. So you know 8 will be one part of the factory, right? And after that, you focus on the variable. So the variable, we have m to the power 3, m to the power 2, and a single m. So you know the single m will be a part of the JCF, right? And then after that, you notice that there's a on the numerator. Okay, you notice that there's a n to the power 3, n to the power 2, and n to the power 3, n to the power 3 again, and then so n to the power 2 will be the common one and the greatest one, right? So we have n to the power 3, n to the power 2, n to the power 3. So obviously n to the power 2 is the greatest and the common one, right? It's the greatest and the common one, right? So right here in this question we got 8 n to the power 2, right? So we got 8m n to the power 2 as the greatest factor for all of those 3 terms. For all of those 3 terms, right? For all of those 3 terms. And then all the thing left is you have to factor it. So 8 multiplied by 2 is 16, right? So you write it down 2. And multiplied by m to the power 2 is m to the power 3, right? And n to the power 2 multiplied a single n is equal to n to the power 3, right? And then we have a plus, and you know that n multiplied by 3, sorry. So you know that 8 multiplied by 3 is actually 24. So you write it down 3, right? And then m multiplied by m is equal to m squared. So you write it down m, right? And then we have n squared and then n squared. So we don't have to write down anything for n, right? So we have a negative 8 multiplied by 5 is actually equal to 40, right? 8 multiplied by 5 is actually 40, right? And m is the same thing, right? And then what we have is n to the power 2 multiplied by n is equal to n to the power 3, right? So now we finish the factory, right? Now you finish the factory, and then we just write it down the denominator. Right? And then you see 8 and 8 get cancelled, and get cancelled, n squared get cancelled, right? And then that's leave our solution, right? So which is 2n squared n plus 3n minus 5n, right? So now you can see everything can cancel, and then we have only our solution left. Okay, so that's for question 3. Let's move into question 4. So as you see, the question 4 is the same thing, right? It's the same thing, but it's just a little bit more valuable, right? So question 4 is the same thing, but it's just a little bit more valuable. So let's just do it, okay? So basically, let's focus on the numerator first. So as I always say it, okay, so let me write it down again. Let me write it down. So you always want to find the JCF, the greatest common factor first. Okay, so now I will show you guys how to actually find it. Alright. So you can see on the top we have on the numerator. So right now we're trying to find the greatest common factor for the numerator. Okay, so you can see the number we have for the number we have 2, 3, and then -1. So there's no greatest common factor for the number, right? Because we just cannot find it, right? So we have 2, 3, and -1, and then you know, for those the greatest will be 1, right? So the 2 equal to 2 multiplied by 1, 3 equal to 3 multiplied by 1, and then -1 equal to -1 multiplied by 1. So 1 is actually the number 1 is actually part of the JCF, and you got for 1 you don't actually have to write it, right? So now you focus on the variable. So what we have for variable is x to the power 4, x to the power 3, and a single x, right? So the single x will be a part of the JCF, because the x is the most common one, right? And it is the greatest, right? And then looking at y to the power 4, y to the power 3, and then y to the power 2. So you write it down y to the power 2, right? And then for z to the power 4, z to the power 3, z to the power 3. So you know z to the power 3 is actually the greatest common factor, and you know it's a part of them, right? So now you finally find the JCF, which is x y squared z cubed, z to the power 3, right? So we have to, you know, now we have to do in the factory part. Right, so now we have to do in the factory part. So you write it down 2 and the x to the power 3, y to the power 2, and a single z, right? And then plus 3 x to the power 2, y, and no z, right? Then we have a minus x. So x and x. So we don't have to write x, and then we don't have to write y to the power 2, and then we don't have to write z to the power 3. So it just is -1, right? As you can see, on the last term is actually equal to the greatest common factor, right? So the last term x y to the power 2, z to the power 3 is actually the same as the greatest common factor. So you just write it down -1. Okay, and for now we finish our factory. We finish our factory. Well, we finish it. Okay, so now you can see x and x get cancelled, y squared get cancelled, z to the power 3, z to the power 3 also get cancelled. Now the only thing left is the solution, right? So we have 2 x to the power 3 y to the power 2 z plus 3x to the power 2 y minus 1. So this is our solution for question 4. Okay, this is the solution for question 4. Okay, so let's move to question 5. So for question 5, since we haven't talking about anything about factory currently, so we're gonna, if you actually, so basically way to solve over here, the way to solve, one way is factory. Okay, and it is the farthest way. It is the fast way. And another way over here, what we have to, another way is the old method. Old method is slow. Okay. So over here, since we haven't talking about anything about factory, so we were doing the old method, which is kind of slow. Okay. But I was talking about factory real slow. But since we haven't talking about anything about factory, because the thing about factory are currently, I just talking a little bit. I just talking a little about the JTF, but that just help us to actually that way it just basically help us to much more easy to find the solution. But over here, since we haven't talking about anything about the factory, which is the fast way, the fast way to solving the problem, we haven't talking about anything about factory, so we basically just gonna using the old method, okay, which is slow. Okay, I'm just gonna show you guys how you actually solving this problem with the old method. Okay, with the old method. So I think you guys already see this part, so I just gonna erase it. Okay, I'm just gonna erase it, and basically the old method you have to write it down in this kind of way. Okay, you have to write it down in this kind of way. So the old method over here is we put the, you try to divide it, right? That's exactly how you divide things, right? So that this is basically how you actually divide things, right? Okay, so basically the old method is basically you have to divide things, and you can see over here we have a x plus 3, right? So you have an x plus 3, so you want to make it equal. You want to make it equal to x squared. So therefore you have to put an x over here, right? You have to put an x over here, and then you actually using x multiply x plus 3, right? So over here, so basically this is how the old method is gonna work, and how you actually solve it. Okay, so basically over here, why you putting x? Why you putting x is because x squared. Okay, it's just simply because x squared. You want to make it equal to x squared, right? So that's why you multiply by x. So x multiplied by x is gonna be x squared, right? And then 3 multiplied by x is gonna be positive 3x, right? So that's basically how the old method is gonna work. And then you basically want to subtract fraction. So basically we have x to the power 2 plus 5x, and then for now you just ignore the positive 15. Okay, so for now we have x to the power 2 plus 5x, and then you just simply ignore 15, the positive 15. Okay, and then we have x to the power 2 plus 5, 8x Okay, so let me repeat one more time. X to the power 2 plus 8x minus x to the power 2 plus 3x. Okay, so let me put it down the bracket. So you want to minus it, right? So we have x to the power 2 minus x to the power 2 is equal to 0, and then we have 8x minus 3x, so it's gonna be 5x, right? So we have, okay, so we have, let me repeat one more time over here, the process. Okay, so we are actually trying to subtract them. So we are actually trying to subtract. Okay, subtract. So we have x to the power 2 plus 8x minus x to the power 2 plus 3x in the bracket. Okay, so it's just going to become x to the power 2 minus x to the power 2, which is 0, right? So 0, right? So now we have 8x minus 3x. So you write it down 5x, right? So after 5x, after you write down 5x, and then it does 15, right? Okay. So after the process, we have this. We have 5x plus 15. So you may ask me, so for the number 15 over here is always going to be 15, cause here is actually plus 0. Okay, now it makes sense, right? So we have a plus 0. Okay, so now it makes sense, right? So basically over here, what you have is basically, basically 15 minus 0, right? So it's basically 15 minus 0, so it's just basically 15, right? So now you can see over here we have a 5x and then we have a single x, so therefore you want to actually multiply by 5, right? So remember, you're always trying to making the same term. Okay, so you want to making the same term. You want to make the same term and then you want to get rid of it, right? So at the beginning we multiply by x, right? So we multiply by x over here. Why we multiply by x? Because we want to get rid of x squared, right? We want to get rid of x squared. So you can see the process over here. You can see the process over here is that x squared minus x squared. So we get rid of x squared, and the same thing also happened over here. We have a 5x plus 15. So you want to cancel out 5x. So therefore you have to multiply by 5, right? So if you multiply by 5 with x plus 3, so you want to multiply by 5 with x plus 3. So it just becomes 5x plus 15, and then you try to minus it, right? You want to minus the whole thing. So now it just becomes 0, right? Okay, so you guys get it, right? So you guys does get it, right? Okay. So you want to cancel those terms, right? At the beginning, you multiply by x because you want to cancel x squared, right? So you multiply by x, it just becomes x squared plus 3x, and then x squared get cancelled, right? That's always the steps. Okay, so whenever you're doing it, you always follow this kind of. You always want to get rid of it. Okay, you want to cancel all those terms. You want to cancel it. Okay, that's the basic idea. Okay, and why you multiply by 5? Because you want to cancel 5x, right? You're using 5 multiplied by x plus 3, so it becomes 5x plus 15, and everything get cancelled. Everything becomes 0, and therefore x plus 5 is our final solution. Okay, x plus 5 is our final solution for this problem. Okay, x plus 5 is our solution for the problem, for this problem, because everything already cancelled out, and the thing left is x plus 5. Okay, solution. Okay, so x plus 5 is the solution because everything is already cancelled out. right? Okay. Okay, so let's move into question 6. All right. Again, question 6 is almost the same step, right? We just want to take a look about the other two questions. Okay, so for now, let's just focus on question 6. Okay, let me drink some water first. Okay, excuse me, right? So excuse me. So let's do question 6 in the fast way. Okay, in the fast way, cause I think I already explained most of the really important things right now. So right now I'm just gonna show you guys how you actually solving those kind of problem really fast. Okay, so it's actually x plus 5. Sorry, x plus 5. So what we have is x to the power 2 minus 2x minus 35, and then we divide x plus 5, right? So we have x squared over here. So therefore you want to multiply by x, right? So you want to cancel x squared. X plus 5 multiplied by x, it just becomes x squared plus 5x, right? Okay. Right, so you want to cancel x squared, so that's why you multiply by x. X multiplied by x plus 5 is x squared plus 5x. And then right here you actually want to cancel it, right? You want to cancel it. X squared minus x squared, it becomes 0, right? And then negative 2x minus 5x, it becomes negative 7x, right? And then minus 35. Right, so now you actually want to cancel negative 7x, right? So right now you want to actually cancel negative 7x, so therefore you have to multiply negative 7, right? So you want to cancel negative 7x, so therefore you multiply negative 7, right? So x plus 5 multiply negative 7, it becomes negative 7x, and then negative 35, right? Right, okay, negative 7x minus 35, and then you want to minus it, right? You want to minus it. Negative 7x plus 7x equal to 0. Negative 35 plus 35 equal to 0. So we got 0 left. So you know the answer is going to be x minus 7, right? So you know the answer is actually x minus 7. All right, so this is the solution for question 6. Okay, so let's move into question 7. So for question 7, you may feel like, it's a little bit different, right? It's a little bit different, right? So let me show you the way how to do it, even it is a little different. So what you can see over here, what we have is 4x squared plus 6x minus 25, right? And then divided 2x plus 7, right? So we divided by 2x plus 7. So as you can see, as the first term, what we have is 4x squared, right? So we have a 4x squared. So we want to cancel this term, right? How we cancel this term? By multiply 2x, right? So we want to multiply 2x plus 7. We want to multiply 2x with 2x plus 7, right? So you can see 2x multiplied by 2x is actually 4x squared, right? And then we have a plus 7 multiplied by 2x is actually 14x, right? 7 multiplied by 2x is actually 14x, right? And then further on is you want to minus it, right? So 4x squared minus 4x squared is equal to 0, right? And then what you got is 6x minus 14x. So it's actually minus 8, negative 8x, right? It's actually negative 8x, right? So you have is 4x minus 4x equal to 0. 6x minus 14x is going to be negative 8x, right? It's actually negative 8x. And then you minus 25, right? So right now you want to actually cancel negative 8x, right? So you want to cancel negative 8x. So therefore you have to multiply negative 4, right? So you want to cancel negative 8x. So therefore you have to multiply negative 4 to 2x plus 7, right? So 2x multiplied by negative 4, it becomes negative 8x, right? And then we have negative 4 multiply 7, right? So we have negative 4 multiplied by 7, so it's negative 28, right? So here okay, 2x multiplied by negative 4 equal to negative 8x, right? And then we have 7 multiplied by negative 4, so it's negative 28, right? Okay. And further on, we want to cancel those terms, right? We want to actually cancel it. So what you can see over here is negative 8x plus 8, negative 8x plus 8x, it is equal to 0, right? And then we have negative 25 plus 28, so it's gonna be 3, right? Okay, so negative 25 plus 28, negative 28 plus 28, so it's going to be positive 3, right? So now we actually got a remainder, right? So this is called a remainder. So now you may ask me, how can we get rid of 3, right? So you may ask me how you can get rid of 3, and the answer is you don't have to get rid of, because this is already the end point, right? Because 3 there's no way we can actually get rid of it. Okay, so up on this point, since 3 is the integer, there's no way we can actually get rid of it anymore. So instead of get rid of you may ask me, right now instead of get rid of it, because there's no way we can actually get rid of 3. So right now we should really focus on how we actually writing the answer of it. Okay, so let me show you guys how you actually write the answer for this problem. Okay, so you see we have a 2x minus 4 as always. This is gonna be a part of the solution. Okay, this is gonna be a part of the solution. Okay, and then another part of the solution. Since we have a 3 as the remainder, we have to put 3 at the top, and then okay. So basically, this is the way how you actually write the solution if you having a remainder. Okay, so this is the way how you actually writing the solution if you have a remainder. Okay, you still, because 2x minus 4 is always going to be is the solution. Okay, 2x minus 4 is a part of the solution. Let me write it down. Part of solution. And since we have a 3 as the remainder, okay, so 3 is the remainder. Let me write it down a little more clear, I guess. So therefore you need to write it down in this kind of way. Okay, so since 3 is the remainder, So you just write it down 3 over 2x plus 7, in this way, okay, in this way. This is kind of like really important. You have to, if you have a remainder, because here you have a remainder 3, so you have to put 3 on the denominator, and then 2x plus 7. Since over here 2x plus 7 is the remainder. 2x plus 7 is actually what we divided, right? So you just write it down 3 over 2x plus 7. Because this is the way how you actually write for the remainder. Okay? Right? Okay, so now let's move into question 8, I believe. So question 8, you look at it, you feel like, it's quite confusing, right? It's actually quite confusing. So they're still using the old method, I guess. Okay, so of course, we haven't learned anything about the factory yet. So right here, I'm just going to show you guys how you're using the old method. Right? How you're using the old method. It's a little bit slow, but we can still use it, right? And maybe, if you knowing all the ways is always good, right? So here, what we have is 2x to the power 3 minus 3x to the power 2 plus 4x plus 4, and then we divide 2x plus 1, right? We divide 2x plus 1. As always, you can see we have a 2x to the power 3, so we actually want to get rid of it, right? So we actually want to get rid of it. So how we actually get rid of it? So we have to multiply x to the power 2, right? So we have to multiply by x to the power 2. 2x multiply x to the power 2 become 2x to the power 3, right? And then we have positive 1 multiply x to the power 2, so it just basically become positive x to the power 2, right? Okay, so now we minus the whole term. 2x to the power 3 minus 2x to the power 3 becomes 0. Negative 3x to the power 2 minus x to the power 2 become negative 4x to the power 2 plus 4x, right? So now we actually want to get rid of negative 4x to the power 2, right? So we want to actually get rid of it. So we have to multiply negative 2x, right? So we have to multiply negative 2x. Negative 2x multiplied by 2x, right? So negative 2x multiplied by 2x is negative 4x squared, right? So it's write down negative 4x squared, and then we have negative 2x multiplied by 1. So it's just simply negative 2x, right? And then, as always, you have to minus it. Negative 4x plus 4x squared. Negative 4x squared minus negative 4x squared plus 4x squared equal to 0, right? Equal to 0, right? And then we have positive 4x. We have positive 4x plus 2x equal to 6x plus 4, right? Okay. So now you actually want to get rid of 6x, right? So you want to get rid of 6x by multiplying 3, right? So you want to get rid of 6x, so you have to multiply by 3, right? 2x multiplied by 3 becomes 6x, right? And then positive 1, okay, and then positive 1 multiplied by positive 3, it just becomes 3, right? It just becomes 3. So again, we want to cancel it. 6x minus 6x equal to 0, right? And 4 minus 3 is equal to 1, right? 6x minus 6 is equal to 0. And then 4 minus 3 is actually equal to 1. So we got 1 as a remainder, right? And this is the solution, right? So as I told you guys how you actually write the solution. So first of all, you have to write the solution, a part of the solution, right? So you write it down, x squared minus 2x plus 3, right? And how you actually write the remainder, how you actually write another part of the answer for the remainder, you just basically write 1 over 2x plus 1, right? Right, so as I told you guys before, how you actually so the first part of the solution is definitely have to be x squared minus 2x plus 3, right? And the other part of the solution is the remainder. And how you writing the remainder is just basically the remainder over here is 1, so it's going to be 1 over 2x and 1 over 2x plus 1. Okay, 1 over 2x plus 1. So this is the full solution. So basically this part is the full solution for question 8. Okay, so this part is actually the full solution for question 8. Alright. Please, there's no many questions left. Finally, there's not many questions left. Okay. Okay. So right now, let's see how many. Okay, so we still got some question. Right, let's try to be focused right now. So for question 9, since we are lack of space, right? I actually didn't put a lot of space over here. Okay, so let me actually drive down a little bit. Input some space. Okay. No. Actually not this part. I'm glad it's already going back. Okay, I think right now it should be good. Okay, so let's doing those questions a little bit more faster. Okay, just basically doing those questions a little bit more faster. For now, we're just gonna show you guys how we actually doing those questions fast. Okay, so as always, you have to write it down the question. So we're gonna solving those questions in the old method. Right, in the old method. So over here you have to multiply by 2x to the power 2, right? So we want to get rid of 8x to the power 3, right? So we basically multiply 2x to the power 2, right? So multiply 2x to the power 2, right? So we want to multiply it, right? Okay, so actually, you know, we actually have to write it down over here. 2x to the power 2. We have to actually write it down over here. Alright? So basically what we have is 4x. Okay, so we have as 4x multiplied 2x squared. So we have 8x to the power 3, right? And then we have a positive 2x square, right? And as always, we want to minus it, right? 8 is 8x to the power 3. It just get cancelled, right? And then negative 6x to the power 2 minus negative 2x to the power 2 become negative 8x to the power 2 plus 2x, right? So now we actually want to get rid of this term. We want to cancel negative 8x to the power 2, right? So we just simply multiply negative 2x, right? So we just simply multiply negative 2x. So 4x multiplied by negative 2x, it just becomes negative 8x squared, right? And then we have positive 1 multiplied by negative 2x, right? So we have positive, let me erase it. We have positive 1 multiplied by negative 2x, so it just becomes negative 2x, right? Okay, so now we want to actually cancel everything, right? So we have negative 8x squared plus 8x squared equal to 0. And then we have a positive 2x. We have a positive 2x plus 2x equal to 4x, right? So it's equal to 4x. Okay. So up on this point, we can actually no longer cancel anything more than this. We just cannot cancel anything more than this, because 4x is the thing remain, right? 4x is actually the thing remain, but you still maybe want to ask me, oh, okay, so actually over here we can actually cancel more terms. Okay, so we are actually able to cancel more. So basically right now I'm going to show you the way. Okay, I suddenly just realized it. So over here, what you can see, we have a 4x plus 1, right? And then we have a 4x. So right now we actually want to get rid of 4x, right? So it's actually equal to 4x plus 0, right? Okay, over here what we have is 4x plus 0, right? So how we can actually get rid of 4x over here? We just simply multiply positive 1, right? So we just simply multiply positive 1. And then it just basically, let me move it down a little bit. Okay, we multiply by positive 1, it just becomes 4x plus 1, right? 4x multiplied by 1 equal to 4x. Positive 1 multiplied by 1 is equal to 1, right? So now we actually want to cancel them, right? So 4x minus 4x is equal to 0. 0 minus 1 equal to negative 1, right? So over here what we have is 0 minus 1, right? So 0 minus 1 is equal to negative 1, and then negative 1 is the remainder, right? So as always, you should know that how we writing for the remainder is basically this way. Okay, it's basically this way. 4x plus 1 and then negative 1. So this is going to be the full solution for question 9. Right? Okay. Sorry for my mistake a little bit before, but right now I think we got the solution, right? So we got 2x squared minus 2x plus 1, and then we had a negative 1 as the remainder. So you just write it down, negative 1 over 4x plus 1. Okay, so we write it down a negative 1 over 4x plus 1. Okay. And that's it for question 9. Alright, and after that we're gonna move into question 10. So question 10, let's do it in the old-fashioned way. I know it's quite long, to keeping. I know it's quite long, but still we have to do it in the old-fashioned. Okay, because we haven't learned anything about the factory yet, right? So after we learn how to do in the factory things, I will surely make you guys understand how we actually doing things much more easy. But for now, I think for question 10, it may be the question for you guys to pause the video and then try to do the question by yourself. Okay, try to do the question by yourself. Okay, so now let's do the question together. As always, you have to write, but the old-fashioned way require to actually solve in this kind of way, right? And then we see a x. Oh, okay. So basically, for this question, okay. So basically, I just want to. Okay. So actually, before we actually putting things, before we actually doing the old-fashioned way, for the thing at the beginning, we have to do it is we have to arrange the numerator in the order way. Okay, in the power. So you can see there is a x. So you can see there is a 2x to the power 3, right? X to the power 3 is the highest power. So you want to make sure you put the highest power as the first term, and then we have x to the power 2. So you put it on the second term, and then we have negative 18x plus 32. So remember, when you're using the old-fashioned way, you always want to arrange those variables in the highest power. Okay, with the highest power. Okay, so here let me put a reminder. Old method always arrange from highest power to lowest. Okay, so we have to. Okay, so that's the key. This is the key detail. Okay, always arrange from highest power to lowest power. So now, right? So now we can actually writing things in this. Now we can actually solve it with the old method. Okay, so you write it down, and then we divide x plus 4, and then now the first term we want to cancel is 2x to the power 3, right? So we multiply 2x squared, right? So that's the term we multiply, right? So that's basically the term we want to multiply, right? So we have x multiplied 2x squared, it becomes 2x to the power 3, and then we have 4 multiplied 2x. We have 4 multiplied 2x squared is equal to 8x squared, right? Equal to 8x squared, 8x squared, right? And then now, as always, we have to cancel it, right? So 2x to the power 3 negative minus 2x to the power 3 equal to 0. X to x squared minus 8x squared, it becomes negative 7x squared, right? So what we have is x squared, positive x squared, minus 8x squared, right? Minus 8x squared becomes negative 7x squared, right? And then we write it down. We write it down negative minus 18x, right? So now the term we want to get rid of is negative 7x to the power 2, right? So we have to multiply. Negative 7x, right? So we have to multiply negative 7x over here. right? So we multiply negative 7x. So x multiply negative 7x. Let me moving down a little bit. It just basically become negative 7x squared, right? 4 multiply negative 7x become negative 28x, right? Okay. 4 multiply negative 7x, it becomes negative 28x, right? Okay. So as always, we want to minus it, right? Negative 7x to the power 2 plus 7x to the power 2 is equal to 0, right? And then what we have is negative 18x plus, right? So plus 28x is equal to 10x, right? 10x plus 32, right? Okay. And now we want to cancel out the 10x, right? We want to cancel out the 10x. So we multiply by 10, right? X multiplied by 10 is actually equal to 10x, and then is 4 multiplied by 10, right? 4 multiplied by 10 is actually 40, right? And as always, we want to cancel out 10x minus 10x equal to 0, right? And then 32 minus 40 is equal to negative 8, right? 32 minus 40 equal to negative 8, right? Negative 8 is the remainder, right? Is the remainder, right? So now we actually solving the problem, right? So the whole solution will be equal to 2x squared minus 7x plus 10 plus x plus 4 negative 8, right? So this is the full solution for question 10, right? So at the top, this is just gonna be will be definitely a part of the solution, right? And how we write a solution for negative 8, right? So how we actually writing the remainder for negative 8, it's just gonna be negative 8 over x plus 4, right? Negative 8 over x plus 4, right? Okay. So now we finish the question for the easy part. Okay. Okay, so now we actually solve the question for the easy part. Okay. Also, I want to say it. In this section, there's a mathematical question. This mathematical question, and I just want to make sure you guys also understand it. That's why I'm spending a lot of time on this. Okay. Okay. So now, as you can see over here, we got more difficult question. Okay, over here we actually got more difficult question over here. So we got totally 3 questions over here. So let's just solve it one by one. Okay, let's just solve it one by one. Oh, so actually, for those really difficult questions, you can also pause the video. You can also pause the video and try to do it by yourself. Okay, for those really difficult questions, you can also pause the video and then try to solve the question by yourself. Otherwise, I will also fully explain it. But I'm okay. But if you can do it, if you can actually do it, then you at least try it. Okay. Yeah. Okay. Okay. So right now, we're just doing those questions one by one. All right. So as I said before, the old method, right? The old method way. So you just basically write it down x to the power 3 plus 2x to the 2x2 plus 3x plus 6 divided by x to the power 2 plus 3, right? As always, you want to get rid of x to the power 3, right? As always, you want to get rid of x to the power 3, right? So you basically multiply by x, right? X, so you basically multiply by x, right? So let's slow down, okay? X to the power 2 multiplied by x is x to the power 3, right? And then we got 3 multiplied by x, right? So we got what we have over here, we have a 3 multiplied by x, which is equal to 3x, right? So which is equal to 3x, right? So over here, the term in the middle, what you write is just 0x squared, okay? And then as always, we try to minus it, right? So we try to minus it, right? So what we have is x to the power 3 minus x to the power 3 is equal to 0, right? And then what we have the left is 3x minus 3x is also equal to 0, right? It's also equal to 0, right? And then what we have for 2x to the power 2 minus 0 is equal to 2x to the power 2 plus 6, okay? So let me repeat one more time, okay? X to the power 3 minus x to the power 3 is equal to 0, right? 2x to the power 2 minus 0 to the 0x to the power 2 is actually equal to 2x to the power 2, right? And finally is 3x minus 3x is equal to 0, right? Okay? Okay, so the thing we have to get rid of right now is actually 2x to the power 2, right? So the thing what we have to get rid of right now is 2x to the power 2, right? So we multiply by 2, we plus 2, right? So we multiply by 2, right? Right? So for now what we have is that we use x to the power 2 multiplied by 2, right? So we use x to the power 2 multiplied by 2, which is 2x squared, right? And then we have 3 multiplied by 2 is equal to 6, right? And then as always, we want to cancel those terms, right? 2x squared minus 2x squared is equal to 0, right? 6 minus 6 is equal to 0, right? So now we solve the problem, right? And the remainder is actually equal to 0, right? So we know the solution will be x. We know the solution is actually equal to x plus 2. But you may also ask me why you don't write the remainder for 0. Why you don't write the remainder for 0? Because either we write the 0, right? Even we write the 0 as this term, it's still going to be 0, right? It's still going to be 0, right? So basically that's why, you know, if you have a remainder 0, you just write down the solution. We just write down the solution x plus 2. Okay. Alright. So now let's moving on to question 2. Okay. So question 2 was, as always, you write it down x to the power 4 plus x to the power 2 minus 5 divided by x to the power 2 minus 2, right? Okay, so first of all we want to get rid of x to the power 4, So you multiply x to the power 2, right? So right now what we have is x to the power 2 multiply x to the power 2, so it's x to the power 4, right? And then we have negative 2 multiply x to the power 2, so it's negative 2x to the power 2, right? Let me cancel this, sorry. So now, as always, we want to subtract it, right? Negative to the power 4 minus negative to negative x, x to the power 4 minus x to the power 4 is equal to 0, right? X to the power 2 plus 2x to the power 2 is equal to 3x to the power 2 minus 5, right? So again, x to the power 4 minus x to the power 4 equal to 0, right? X to the power 2 plus 2x to the power 2 is equal to 3x to the power 2 minus 5, right? So right now we want to cancel the term 3x to the power 2, right? So we multiply by positive 3, right? So we multiply by positive 3, right? So you multiply by positive 3, right? So x to the power 2 multiplied by 3, x to the power 2 multiplied by 3 is 3x to the power 2, right? And then negative 2 multiplied by 3 is actually negative 6, right? So negative 2 multiplied by 3 is actually negative 6, right? So now, as always, we want to subtract the terms, right? 3x squared minus 3x squared is equal to 0, right? Negative 5 plus 6 is equal to 1, right? So negative 5 plus 6 equal to 1, right? So we have 1 as the remainder, right? So we have 1 as the remainder, right? So you know how to actually write down the answer, right? So a part of the answer will be x squared plus 3, and then we need to write down the solution for the remainder. For remember, sorry. Okay, it's over here, I guess. Okay, let's go back. Okay, so you write it down x squared plus 3 as part of the solution. So now we have to write down the solution part for the remainder, right? So we have a remainder 1, so you write it down 1 over x squared minus 2, right? So now this is the full solution for question 2, right? So now this is the full solution for question 2, okay? Right? Okay, so we are on actually our last question. Alright, so we are actually on our last question over here. So pause the video and try this question by yourself. Okay. Okay, so now let's do this question. So basically, before we actually do this question, I'm gonna tell you guys some easy way to actually doing this question. Okay. So remember, one of the property what we have is a plus b is equal to a plus b, a minus b is equal to a squared minus b squared, right? Okay, so we were going to using this property over here. Again, a plus b, a minus b is equal to a squared minus b squared, right? So over here, the thing what you're gonna do, since we are actually going to talking about factory really soon. I may just going to show you guys, how you actually. I'm just going to show you guys a little bit early how we actually doing factory. Okay, so over here you are actually able to factory this term, x to the power 6 minus 1. Okay, so you write it down, x to the power 6 minus 1 over here, right? And you can see we can actually using this property. Right? X to the power 6 minus 1 is actually equal to x to the power 3 plus 1 and x to the power 3 minus 1. Right? Okay, so let me verify it. Okay, so we have x to the power 3 plus 1 and then x to the power 3 minus 1. Right? So as the property on the right hand side say it, a plus b, a minus b is equal to a squared minus b squared, right? So what we have is x to the power 3 plus 1, x to the power 3 minus 1. So it becomes x to the power 3 squared minus 1 squared. So it just equal to x to the power 6 minus 1. Right? So that means it is equivalence, right? Because those are the same thing, right? Those are the same thing, right? So you can actually write it down. You can actually factory x to the power 6 equal to 1 equal to. You can actually, so it's true. X to the power 3 plus 1, x to the 3 minus 1 is equal to x to the power 6 minus 1, right? So over here we can actually write it down, x to the power 3 plus 1 and then x to the power 3 minus 1. And on the bottom what we have is x to the power 3 minus 1. So x to the power 3 minus 1 it just get cancelled, right? And then all the same left it just becomes x to the power 3 plus 1. Right? Okay. So this is the solution for question 3. Okay, so this is the solution for question 3. Okay. Oh. Excuse me. So we actually got ourselves a last really difficult question. Sorry, I just noticed that. Okay, sorry, I just noticed that. So we are actually not done yet. Okay. Again, for these questions, because all the question over here is quite difficult, so that's worth a try. Okay, so pause the video and try to do the question by yourself, and then, okay. Okay, so now let's try to solve the problem. Let's solve the problem together. Okay, so here let's say that you need to find the value. You want to find the value of C, right? You want to find the value of C so that those two equations are equivalent, are equal, right? So look, you're looking at the right hand side. It's just simply x plus 1, right? So we cannot do anything more than this. We cannot simplify anymore. So the key over here is that we have to using the old method on. We have to using the old method on the left hand side. Okay. So our first step over here is actually using the old method on the left hand side. Okay, so let's just write it down, the equation. So we have x to the power 3 plus x to the power 2. So let me zoom in a little bit. Okay, I'm just trying to see. Let me zoom in a little bit. So you just write it down, x to the power 3 plus x to the power 2, and then plus x plus c, right? And then we divided by x to the power 2 plus 1, right? We divided by x to the power 2 plus 1. So as all the time, we want to get rid of, we want to cancel the term x to the power 3, right? So we have to multiply by x to the power 2. So now x to the power 2 multiplied by x is equal to x to the power 3, right? It's equal to x to the power 3, right? And then we have positive 1 multiplied by x. It does equal to x, right? And the middle term, what we write is plus 0x squared, right? Okay. So now, as always, we want to cancel out the term, right? So I will say it step by step, okay? So x to the power 3 minus x to the power 3 is equal to 0, right? And then x to the power 2 minus 0 is going to be x to the power 2, right? And then x minus x equal to 0, right? So all the thing left is x to the power 2 plus c, right? So all the thing left for now is x to the power 2 plus c, right? So now we want to get rid of, want to cancel all the term x to the power 2. So we just multiply by 1, right? So we just multiply by 1, right? So now what we have is x to the power 2 multiplied by 1. So it's x to the power 2, right? And then what we have is 1 multiplied by 1 is equal to 1, right? And as always, we want to cancel, we want to subtract it, right? X to the power 2 minus x to the power 2 is equal to 0. C minus 1. It's just going to be c minus 1. Since we don't know the value for c, right? So here, again, x to the power 2 minus x to the power 2 is equal to 0. And then we have a positive c minus 1. So we just write it down c minus 1 because we don't know the value for c, right? Now we actually find the solution for the left hand side, right? We actually find the solution for left hand side, which is equal to, okay. So now let's go back to the problem, okay? So now you already solved the left hand side, so we write it down x plus 1 plus c minus 1 over x squared plus 1 is equal to x plus 1, right? Is equal to x plus 1. And you see the problem, you see x plus 1 and x plus 1 is the same thing, right? And since we want to make the equivalence, that means that this term, c minus 1, x squared plus 1 have to be 0, right? Okay, so this is the logic over here, because you see, actually those two terms, x plus 1 and x plus 1 are the same thing, right? Are the same thing. So that means that, the middle term c minus 1 over x squared plus 1 have to be 0, right? To make those two equations equivalent, right? So now we are actually solving this, okay? So you can see over here what we have is c minus 1, and then we have x squared plus 1 multiplied by 0 which is equal to 0, right? So over here, this term 0 multiply anything is equal to 0, right? So 0 multiplied by anything is equal to 0, right? So what we have right now is c minus 1 is equal to 0, and then c is just equal to 0 plus 1 is equal to 1, right? So c is just equal to 1, right? So now we actually find C, right? We actually find C, right? Okay, so now the problem is solved, right? Okay, everything makes sense, right? So the answer for this question is the value for C is equal to 1. Okay. Okay, so that's everything for this topic. So basically, I think in this section, we actually talk for the summary. Okay, for the summary part in this topic, we just basically talking about dividing polynomial, and then since cause there's not many really important properties, so we just basically go straight to some real example, right? And that's basically it is, right? So basically, since you guys watching, up on this point, I think you guys already watching the full video, right? So thank you guys been watching the whole time, okay? The whole time. I hope you get a lot, by watching all the steps way through from the beginning up on this point, okay? Up on this point. So please subscribe to my channel, right? So please subscribe to my channel, like the video, right? So like the video, and also click the notify button on, right? So click the notify button on. Okay, I will try to upload more videos so as possible. Okay. And if you still have some question, please leave a comment below. Does it helpful, or do you like the video, right? Or if you still having some question, I will apply them as soon as possible. Okay? Otherwise, see you guys in the next video. Okay? Good luck.